Well, hello there again, friends. Today is 9/11/2022, and today is the Odin Project Vlog Day 146. And been a hot minute since I got a video up, but nevertheless, I'm back, and I completed step 4 and 5. So without further ado, let's get started. So on the project here of balanced BST, and number 4 says write an insert and delete function which accepts a value, and an insert delete. You'll have to deal with several cases for delete, such as when a node has a child or not. If you need additional resources, check out these two articles on inserting and deleting, or this video which with several visual examples. Highly encourage you to look at these, especially the video goes in pretty good detail on how to traverse the tree and how to add and remove nodes or values that will keep the tree in sync. So again, just like I kind of precursor in my other video, I'm not going to make a a big huge attempt to try to explain that, since it's already explained in the video, and I wouldn't do a very good job with it anyway. But anyway, let's hit the editor and go over insert and delete. And then I did find as well. We'll come back to that. But that is write a find function which accepts a value and returns the node with the given value. So here is the first one is I think is the first one, yeah. Insert. So insert takes obviously the value is the parameter it takes in of the from the user. Root equals this root equals this dot root, like last time in the last video. Actually, no, we didn't do it like that. Sorry, it's been obviously a couple weeks since that one, since I started that one, so I had to remember. But basically, we're going to set default root to this current iteration of the root, or recursion of the root, if you will. If the root is null, though, in this first if statement, we're going to return root equals new node value. So we're going to create, as we looked in previous videos, I won't go over that again, we're going to create a new node, and we're going to give it insert the value of the parameter that's provided from the user. Excuse me. Tourette's is active now. And then that new node value will be given to root, and then we return, and then when we come back through the insert, we will be skipping this because that will not be null anymore. So that satisfies that. So we come down here to the next if. So if root.data is less than value, so basically if what the user puts in to insert, and this recursion and the in-depth knowledge and understanding of this recursion is what I'm not going to go through because I need visual representation. And I'll show you a little bit in the tree below. You can see in my terminal using the prettier print or pretty print. It kind of showcases that. But anyway, so we're going to recursively go through this. So if your value is larger than the data that you're looking at in the current root, we're going to look at root.write, and we're going to keep iterating over with this, inserting, doing inserts, insert functions, or insert methods with value and that the parameter, the value given by the user, and root.write. So which is just keeps recursively, if I say iteratively, I meant recursively, keeps recursively going over this until this is satisfied. So root.write will then be equal to this.insert value again and again and again until the value is no longer larger than the data it's looking at, and then it'll insert that value right there at that position. Else, opposite direction. So basically the else statement here is the only other way is if the value is smaller than the current data it's looking at. We're going to go down the left side and do the exact same recursive method of rerunning the insert method with the value and going root.left. You can kind of see that in here because root.left going down here, as you can see, is decrementing. Root.right going this way is, well, as of here anyway, the first child node, and going right is incrementing. And that's how the balanced BST works, as explained in the video that you should read for your homework, and last video's homework as well. So that's what that does, and then pretty print is just printing that off so we can see it for visual representation, and we're returning root when we're done. And that's the insert function. Similar theme for delete. Sorry, I cannot talk today. I've had some dental work done, so I got a little bit of a lisp now because I have a kind of a partial in my mouth now, if you will. So, yep, that's kind of the thing I've been working on and why I've been out for a while. So, bear with me if I've got a little bit of a lisp here. Hopefully, I'm coming through on the video okay. But anywho, we have the delete method here. So this is going to satisfy the delete function. So this is if we want to go in and delete a node. So we're going to take in the value from the user, and again, root is going to equal this dot root. So and then but this time instead of creating a new node, which we don't want to do because we're deleting, if root is null, and this time we're going to return root. So we're going to return the null back out because in this case the base case is satisfied because the value supplied by the user is null for root, which means that it doesn't exist. So we're going to no, I did not say that right. I'm sorry. We're going to return root, which is null, because the value they wanted to delete was not available. So that's why we're doing that. I'm just going over that, make sure I have that right in my head. Okay. Okay, so we have if root.data is greater than values. This is very similar to the previous recursion we just did in the insert. So we're going to go to the left-hand side. If the value is less than the data we're evaluating against, we're going to go down the left-hand side and recursively go through this with the delete by recalling the delete method over and over again and going down the left side. Else, if the value that the user provides is greater than the current root.data, we're going to go down the right side and recursively call itself again and again and again, going down the right side until it's satisfied. Else, if neither one of those are true, meaning the value is not less and the value is not greater, we're going to have an if here. So if root.left equals null, we're going to return root.right, and then if root.right is null, we're going to return root.left. And that's in the case basically that the value the user's trying to delete is the exact same thing as the data that the root.data that's looking at, the root value. We're going to return the opposite. We're going to say it's null and return the opposite. And then so then after that we have two functions here. We have root.data equals min value of root. So here is basically it's calling a actual helper function that I created called min value, and it's going to take in root, and what it does cuts down here at the bottom here, and what it does is says it's let min equals data.root while root is not equal to null. Meaning, as it sounds, as long as root is available in there and it has a number attached to it or a value, we're going to have root.data equals min, and then root equals root.left. So we're going to basically, since it's a while loop, we're going to iterate down through root.left with that min value, and that's the only reason we're doing that is because we're looking for the minimum value of the root, and so we have to go left. We can't go right because based on how the algorithm works, right goes higher. So we can only go down the left-hand side of the trees to get that smaller number. So we go down to the smallest value until that's satisfied. When root is then null, and we know we're at the minimum value. And we're going to pretty print that out so we can see it for visual representation, and we're going to return min back. And so what happens there then is that becomes root.data, and then we're going to have root.write is going to take on this.delete, root.write, root.data. So basically we're taking the root.data, we just went through here with the min value function, and so this is going to be basically the null case. It's going to represent our very last leg of the left-hand side, and we're going to also supply the delete method, excuse me, with root.write, which is what we are working on up here. If one is provided and then this delete will equal the root.write. So we're going to keep recursively calling root.write until that is satisfied, and then we're going to again do pretty print and return root. Oops. Okay. All right. So I got the find here. So here's if we want the user to be able to find a value in the tree. So we're going to call a value here, a parameter value, which is their input, and then again we're going to do root equals this.root to get the current root. If root equals null, return false. This is what I was trying to explain in the previous base case of the delete, and I think I got myself a little confused on that one. So in this case, if root equals null, meaning there is nothing there at root, we're going to return false. That means that the value that the parameter value that the user provided does not exist in the tree. Either they typed in a number that wasn't there in this example, or they typed in like a letter or something else. Basically anything that's not actually in the tree will return false. So if not, we're going to move down to this if. So if root.data equals value, we're going to return root. So this is if it's shebang, got lucky, the first value they provide is equal to the current this.root. We're going to return that this.root and end. And then we'll just come down here, pretty print, and return root, and be done. Actually, no, it will return root here. Sorry, that's an incorrect statement. It will return the root from this position here, and it will end the find function, or find function. In this instance, because we're inside of a class, this is a method. So if not, we're going to come down here and do root.data is greater than value. So this case is if the value the user provided is less than the current root this.root, we're going to return excuse me, we're going to return I keep wanting to say iteratively, recursively, this dot find value roof.left. So here we're going to recursively go through the find and calling itself over and over and over, going down the left side, because like I've mentioned several times, the left here is the decrementing of the value. So if this if statement is true, that's what we want to do, because we're looking for a value that's less than the current evaluated data. And then else if the opposite, so if the value is larger than the current data value being evaluated, we're going to recursively go through the find and do root.write and go this direction. So we're going up in value until we find it. And once we satisfy it, we will print it by doing a pretty print and returning the root. And so that's it. So basically tying things up here, keeping this video, trying to keep it short and sweet here. I did an insert 8, so if you see here, don't worry about the replication. This is replicating itself because I have the pretty prints inside of the inside of the methods, which, as you know, they're recursively getting called every single time. So the only way to get away from that is I have to put pretty print outside of the recursion, and then it breaks because I can't put it out there because I'm inside of a class and it doesn't recognize pretty print as a function. It only see it as a method when you're inside of a class. So in order to have it do that and have it seen as a function, I have to put it inside the if statement. So it gets out of the scope of the class. So hopefully that kind of made sense. But anyway, that's outside the scope of this this instruction here. So insert 8. So it did it right here. We put 8 in there. It went through root.right and went root.right, 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 and then it's seen null, and so it printed it. Delete 3. So if you notice there's no 3 here, it would have been right here. So we have root.left for root.left 2. It would have been 3 here. And so we delete the 3, or I'm sorry, 3 was up here. Yeah, that's right. 2, and then 3 was here. So we deleted that, and it just deleted it from the end of the tree on root.right on that one. So then at the end here we have find 10, and I put that in accounts.log so it could just be printed out, and it prints out false here because 10 does not exist in our tree. And then if I delete this and put 8 and save it, it'll print off, it'll see it, it searches the tree, do the find method, and it will see 8 in there and print off the node here via balance BST. So data 8 left null, right null, because you know, both children are null here because we're at the end of the tree, and there's nothing bigger than 8 and nothing smaller than 8 to print. So that satisfies that. So that is it. Next time we'll be going into the number 6 left order, or excuse me, level order. 7 probably in order, pre-order, and post-order, and I'll probably do another video. I'm trying to chunk these out in smaller bite-sized pieces, so they're shorter videos and easier to digest, so, and easier for me to explain. So with all that said, please like, share, and subscribe for more content. Let me know in the comment section how you guys are doing with balanced BST. So with all that said again, till next time, see ya!